Open loop testing is used when the device under test, such as a microspeaker in a phone or tablet, cannot be physically connected to the system, so playback and recording are asynchronous. Typically, we load the stimulus signal onto the device under test and play it back during the sequence run, capturing it with a record-only acquisition step. We need to incorporate a trigger into the acquisition step so that SoundCheck knows when to start recording. SoundCheck has 3 different trigger options. Let's take a look at how to use them. Whichever trigger you use, first, you need to create your test stimulus and save it as a WAV file. In this case, we'll take our step sign sweep from 20 kHz to 100 Hz and save it to a WAV file. You could even add an autosave step to your sequence to perform this function. Now let's add a trigger. There are 3 trigger options available in the record-only acquisition step: a level trigger, a level and frequency trigger, and a level and cross-correlation trigger. The level trigger step is our oldest and simplest method. SoundCheck just waits until the trigger level is exceeded on the selected input signal path, then records for the duration entered into the time field, which should be set slightly longer than the stimulus duration. A small offset value can be applied to shift the recorded time waveform relative to the trigger time. In this case, we add 100 milliseconds to the start of the recorded time waveform prior to the trigger time. The timeout value is the amount of time that the step will wait for a trigger event before stopping. Let's run this. Now that we have the recorded time waveform in the memory list, we can continue with analysis, post-processing, and other steps the same way as with a typical closed-loop sequence. If no trigger occurs before the timeout value, the step produces a failed verdict in the sequence editor. We can configure the step to halt on fail, or to jump to an operator message, prompting the operator to test again. Simple level triggers are susceptible to false triggering. Background noise rather than the trigger tone might start the recording. I'll run the sequence again while creating some noise. And you can see here, I triggered the recording with my clapping and we haven't captured meaningful data. Our second trigger option was designed to overcome such situations. The level and frequency trigger requires not only a level threshold to be exceeded, but also a sine wave to be detected. This is more robust and less susceptible to errors due to background noise than the simple level trigger. For this trigger, we create a compound stimulus. Here, our stimulus is a step sign sweep, and we've configured the trigger tone as a 250 millisecond, 1 kHz sine wave. I've placed 100 milliseconds of silence between the 2 components. That's not a requirement. We set both the trigger tone and silence to do not analyze, so we are only analyzing the sweep portion of the recorded time waveform. Let's run it. You can hear the trigger tone at the start, and you can see it on the recorded waveform here. As you can see, it's analyzed just the sweep part of the stimulus to give us our results. Although the level and frequency trigger is adequate for most purposes, it can occasionally register false triggers in noisy production applications where a neighboring line may be playing a similar trigger or sweeping through the trigger frequency. The cross-correlation trigger overcomes this by using a log sweep or chirp instead of a fixed tone trigger. You need the time selective response module enabled in your SoundCheck license to use this option. In the cross-correlation trigger, our fixed trigger tone is replaced by a log sweep or chirp. The chirp should have a duration of 50 to 200 milliseconds and have a frequency range of at least 1 octave occurring within the pass band of the device under test. Now let's select the trigger type, and the compound stimulus from the drop-down list in the acquisition step. Let's run it. You can see our log trip here, and our stimulus, and of course, our results. That's a quick demonstration of how to configure SoundCheck's trigger options. You can find more detailed instructions in the user manual.